All right, so we are here to do a demo on Apache Spark, the next generation of big data. So let's get this started. Why Spark? Why suddenly we need a new technology to take things forward? There is a tool called grep, and there are many such simple scripting tools which might help us what we are looking for to do, right? But they're not scalable. They work only across a single machine, a single processor, and if you increase the amount of data that they are trying to crunch, it gets slower, right? So what's the solution? Hadoop, right? Distributed computing environment, scales across thousands of machines, across clusters, and speeds up your computation somewhat. Now, the technology that we are going to introduce today actually does the same thing in a much smarter way, in the sense it requires much fewer machines and it is computationally much faster. So that's Apache Spark. Fewer machines and faster processing. The testimony for that speed can be given by Reynolds Zinn, one of the core maintainers of the Spark library. So it has been proven officially that Apache Spark is the fastest open source engine for sorting a petabyte. The clear benchmark, if you put down your focus on this end, is here. This is the benchmark. So it runs 3 times faster using 10 times fewer machines. So if I were to look at a Hadoop job that runs for 3 hours on 100 machines, Spark can do it in 1 hour in only 10 machines. So that's the kind of performance optimization we're trying to get. This is one of the core reasons why businesses are shifting their focus from a typical Hadoop-based environment to more of a Spark-based environment. Now let's compare them more. Big data means big code, right? So even if to get started with a MapReduce job, a simple MapReduce job, along with the boilerplate code, you need at least 50 lines of code. Whereas in the Spark paradigm, we can do it in 10. Now why Spark? First of all, it's highly readable. It's free from all the boilerplate code that we see. So it's very expressive. The APIs that are there for implementing Spark are very readable in the form of Scala, Python, Java. All the APIs are very expressive. They're fast and they're very, very unit testable. So Hadoop is the kind of environment where if you're going to run a MapReduce job on an HDFS with hundreds of machines trying to crunch some data, doing some data wrangling, it's not very testable. So you write a job, you run it, you go through some errors, and then you fix it. It is hard to modularize that kind of code, and it's hard to unit test that kind of code. Testability also leads to interactivity, so that's one of the core reasons why we choose Spark, because it's highly interactive in nature, as we'll see in the different environments going forward. It is fault tolerant in nature, so there is no chance that you will lose your data once the correct architecture is set. And the biggest contingency that leverages Spark as a big time technology shift from the Hadoop paradigm is that it has the ability to unify big data.